flammable storage cabinet should be grounded. NFPA 704 Standard System for the Identification of the Hazards of Materials for Emergency Response Section 4.2.1.1 states that flammable and combustible liquid storage cabinets shall be grounded and bonded. NFPA 30 Flammable and Combustible Liquids Code Section 4.36.1 states that flammable and combustible liquid storage cabinets shall be electrically grounded. There are several reasons for grounding flammable storage cabinets. Firstly, grounding prevents static electricity buildup, which can ignite flammable vapors. Secondly, grounding protects against electrical shocks and fires caused by lightning or power surges. Thirdly, grounding ensures the cabinet is at the same electrical potential as the surrounding environment, reducing the risk of sparks or explosions. Approved grounding methods include connecting the cabinet to a building ground system using a ground rod or other approved method, and using a conductive paint or coating on the inside and outside of the cabinet. The purpose of grounding is to provide a safe path for electrical current to flow in the event of a fault. This prevents the buildup of static electricity, which can cause sparks and ignite flammable materials. Grounding also helps to protect people from electrical shock. There are several ways to ground a flammable storage cabinet. One way is to connect the cabinet to a building's grounding system. This can be done by using a ground rod or other approved grounding method. Another way to ground a flammable storage cabinet is to use a conductive paint or coating on the inside and outside of the cabinet. This will help to create a continuous electrical path to ground. It is important to note that grounding flammable storage cabinets is required by many building codes and safety standards. Failure to ground a flammable storage cabinet can result in fines or other penalties. Grounding flammable liquid storage cabinets is essential for safety because it mitigates the risk of fire and explosion by preventing the accumulation of static electricity. Static electricity can be generated by the movement of flammable liquids within the cabinet or by the movement of objects near the cabinet. If static electricity is allowed to build up, it can discharge as a spark, which can ignite flammable vapors. Grounding provides a path for static electricity to safely dissipate to the earth, preventing the buildup of a potentially dangerous charge. Grounding also provides protection against electrical shock. In the event of an electrical fault, grounding provides a low impedance path for current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Grounding ensures that the cabinet is at the same electrical potential as the surrounding environment. This reduces the risk of sparks or explosions that can occur when there is a difference in electrical potential between two objects. The NFPA 30 Flammable and Combustible Liquids Code and the NFPA 704 Standard System for the Identification of the Hazards of Materials for Emergency Response both require that flammable and combustible liquid storage cabinets be grounded. Grounding is typically achieved by connecting the cabinet to a building's grounding system using a ground rod or other approved grounding method. The grounding conductor should be sized appropriately for the anticipated fault current. In addition to grounding, bonding is also important for flammable liquid storage cabinets. Bonding is the process of connecting two or more conductive objects together so that they are at the same electrical potential. Bonding helps to prevent the buildup of static electricity and reduces the risk of sparks or explosions. Bonding is typically achieved by connecting the cabinet to other conductive objects in the area, such as piping, equipment, and structural steel. The bonding conductors should be sized appropriately for the anticipated fault current. The proper grounding and bonding of flammable liquid storage cabinets is essential for safety. By following the requirements of the NFPA 30 and NFPA 704 standards, you can help to prevent fires, explosions, and electrical shocks. To elaborate further, consider the specific scenarios where static electricity can become a hazard. The act of pouring flammable liquids into or out of a container can generate static electricity as the liquid moves and rubs against the container walls. The faster the flow rate, the greater the potential for static buildup. Similarly, the movement of containers or objects near the cabinet can also induce static charges. In dry environments, the risk of static electricity is even higher, as there is less moisture in the air to dissipate the charge. The grounding system provides a continuous and reliable path for these static charges to drain away safely, preventing them from accumulating to a level where a spark could occur. The type of grounding method used should comply with local electrical codes and regulations. A common method is to connect the cabinet to the building's grounding electrode system, which is typically a ground rod or a metallic water pipe that is in direct contact with the earth for at least 10 feet. The connection should be made using a suitable grounding conductor, such as copper wire or a grounding strap. The size of the grounding conductor should be determined based on the size of the electrical service and the potential fault current. In some cases, it may be necessary to use multiple grounding points to ensure adequate grounding. Another method of grounding is to use a conductive paint or coating on the inside and outside of the cabinet. This coating provides a continuous conductive path to ground, even if the cabinet is not directly connected to the building's grounding system. The conductive coating should be applied in accordance with the manufacturer's instructions and should be tested regularly to ensure that it is still effective. In addition to grounding, it is also important to bond the cabinet to other conductive objects in the area, such as piping, equipment, and structural steel. Bonding helps to equalize the electrical potential between these objects, reducing the risk of sparks or explosions. Bonding is typically achieved by connecting the objects together using a bonding jumper, which is a short length of conductive wire or strap. The bonding jumper should be sized appropriately for the anticipated fault current. The grounding and bonding system should be inspected regularly to ensure that it is in good working order. Any damaged or corroded component should be replaced immediately. The inspection should also include testing the continuity of the grounding and bonding connections to ensure that they are still providing a reliable path to ground. It is important to note that grounding and bonding are not the only safety measures that should be taken when storing flammable liquids. Other important safety measures include storing flammable liquids in approved containers, keeping flammable liquids away from sources of ignition, and providing adequate ventilation. Employees who handle flammable liquids should be properly trained in the hazards of flammable liquids and the proper safety procedures. Flammable liquids should be stored in a well-ventilated area away from sources of ignition such as open flames, sparks, and hot surfaces. The storage area should be equipped with fire suppression equipment such as sprinklers or fire extinguishers. Employees should be trained in the proper use of fire suppression equipment. Flammable liquid should be handled with care to avoid spills. If a spill occurs, it should be cleaned up immediately using appropriate spill control materials. Employees should be trained in the proper spill control procedures. Flammable liquid should be disposed of properly in accordance with local regulations. Employees should be trained in the proper disposal procedures. The storage and handling of flammable liquids is a serious matter that requires careful attention to detail. By following the proper safety procedures, you can help to prevent fires, explosions, and other accidents. Let's delve into the specifics of selecting the appropriate grounding conductor size. The National Electrical Code, or NEC, provides guidelines for determining the minimum size of grounding conductors based on the size of the overcurrent protection device protecting the circuit. For instance, NEC Table 250.122 specifies the minimum size of equipment grounding conductors for grounding raceway and equipment. If the overcurrent protective device is rated at 20 amps, the minimum size copper equipment grounding conductor is 12 American wire gauge or AUG. If the overcurrent protective device is rated at 60 amps, the minimum size copper equipment grounding conductor is 10 AWG. If the overcurrent protective device is rated at 100 amps, the minimum size copper equipment grounding conductor is 8 AWG. It is crucial to consult the NEC and local electrical codes to determine the correct grounding conductor size for your specific application. When connecting the grounding conductor to the cabinet, ensure that the connection is mechanically sound and electrically conductive. Use appropriate grounding lugs and connectors that are listed for the purpose. Clean the surfaces of the cabinet and the grounding conductor to remove any dirt, corrosion, or paint that could impede the flow of electricity. Tighten the connections securely to ensure a low resistance path to ground. Regularly inspect the grounding connections for corrosion or damage. Corrosion can significantly increase the resistance of the grounding connection, reducing its effectiveness. If corrosion is present, clean the connections thoroughly and apply a corrosion inhibitor. Replace any damaged components immediately. The effectiveness of the grounding system can be verified using a ground resistance tester. This instrument measures the resistance between the cabinet and the earth. A low resistance reading indicates a good grounding connection. The NEC recommends that the resistance to ground should not exceed 25 ohms. If the resistance is higher than this, the grounding system should be inspected and repaired. Consider the location of the flammable storage cabinet. If the cabinet is located outdoors, it is more susceptible to lightning strikes. In this case, it is especially important to ensure that the cabinet is properly grounded and bonded. You may also want to consider installing a lightning protection system to protect the cabinet and its contents. If the cabinet is located indoors, it is still important to ensure that it is properly grounded and bonded. Even indoors, static electricity can build up and cause a fire or explosion. In addition to grounding and bonding, there are other safety measures that can be taken to reduce the risk of fire or explosion. These include using intrinsically safe equipment, providing adequate ventilation, and implementing a hot work permit system. Intrinsically safe equipment is designed to prevent the release of sparks or heat that could ignite flammable vapors. Adequate ventilation helps to remove flammable vapors from the air, reducing the risk of explosion. A hot work permit system requires that all hot work, such as welding or cutting, be authorized and supervised to ensure that it is performed safely. In summary, grounding flammable storage cabinets is a critical safety measure that helps to prevent fires, explosions, and electrical shocks. Grounding provides a path for static electricity to safely dissipate to the earth, reducing the risk of ignition. The NEC and other safety standards provide guidelines for grounding and bonding flammable storage cabinets. By following these guidelines, you can help to ensure the safety of your employees and your facility. Remember that grounding is just one aspect of a comprehensive safety program for flammable liquids. It is essential to implement all of the necessary safety measures to minimize the risk of fire, explosion, and other accidents.